Alright guys, this is going to be the walkthrough video by request for the probability review we did in class today. I'm going to go through it pretty quickly, so if you have any questions or if I don't understand something enough, or if I don't explain something enough for you, just be sure to bring your questions to class tomorrow. Okay, so first question says, what is the probability that you will choose a consonant? A consonant is a not vowel. Okay, so the vowels are A, E, I, O, and U. So the consonants in flashes, so I'm going to call them C, F, L, A would be a vowel, S is a consonant, C is a consonant, E is a vowel, and S is a consonant. And I'm counting that last S even though we have S in the middle of the word flashes anyway. Okay, so how many of these are not vowels? Well, 1, 2, 3, 4, 5, and there are 2, 3, 4, 5, 6, 7 total letters. Those would be consonants. The vowels would be A and E. That's really all you need to do on number 1. Number 2, Melody made 12 out of 20 goals during soccer practice. Predict how many goals Melody will make in her next practice if she attempts 40. So 12 out of 20 is what her probability is. It's kind of already there for you. So you could keep that, you could simplify it, you could use the decimal, which is going to be 0.6, right? And then what you're going to do to predict is you're going to multiply that by what she is attempting. She's attempting 40 goals, so I'm going to multiply by 40, which was going to be 24. Okay. There are multiple ways to do this. This is just the way that I did it. I saw somebody else do it differently already. Actually, I saw a couple different ways that students have done it differently, but this is just the way that I decided to do it. Number 3, you've got a bag of marbles that contain 4 orange, 3 red, 2 purple, 3 green, and 1 yellow marble. You randomly choose a marble from the bag. So just for convenience sake, I'm going to add these up because I know I'm going to need the total anyway. So 4 and 3 is 7, 8, 9, 10, 11, 12, 13. So there's 13 total marbles. Okay. You select an orange marble, replace it, that's a big keywords right there, and then purple marble. So we want the probability of orange and then the probability of purple. There are 4 orange marbles. Whoops. Actually, is it independent or dependent? Because we're being replaced, it's meaning we're putting it back into the bag. So this would be independent. Okay. We have 4 orange marbles out of 13 marbles, so that's the probability of us drawing an orange. We put that marble we draw back into the bag, so we still have 13 marbles total. And then the purple marble, there are 2 of those. So 4/13 times 2/13. Which is 8 over 169, or if you convert that, it's about 0.0473. Okay. For number 4, you select a red marble, place it to the side. That's telling us whether it's independent or dependent. And then you select a green marble. So because we're putting this to the side out of this bag, it's not going to be in there for the second choice. So this would be dependent. there are 3 red marbles out of 13 starting marbles, but because we're putting this to the side, our totals change. Okay, we lose 1 marble because we're putting it to the side. And then there are 3 green marbles. And the green marbles are not affected from the first selection of the red marble because they're 2 different colors. So take 3/13 times 3/12, and I got 3 out of 52, which is 0.0577. I don't know. Something like that. Okay. Number 5, you select an orange marble. Do not replace it. Tells us if it's going to be independent or dependent. And then select another orange marble. So we've got orange and then orange. Since we don't replace it, this is also dependent. And then we start with 4 orange marbles out of 13 total marbles. We're taking an orange marble out and keeping it out, so our total of orange will go down by 1, and then the overall total will also go down by 1. It's about 0.0769. Okay, so those are independent and dependent marble problems. Okay. Number 6, a bag contains red, green, and blue M&Ms. Probability of selecting a red M&M is 3/7. Probability of selecting a blue M&M is 2/7. Find the probability of selecting a green M&M. So kind of how I would set this up is red plus green plus blue is going to equal the total. Something like that. This just kind of makes sense in my head. The red is 3 out of 7. The blue is 2 out of 7. And the total would be 7 out of 7. So how my brain would work is say, okay, what is that missing variable? 3/7 plus 2/7 plus what 7 gets me 7 out of 7? Well, you can combine these guys right here, and because we're looking to select a green M&M. But you can combine those guys to get 5/7 plus our M over 7 equals 7 over 7. So think to yourself, what 5 plus what gets you 7? And it's 2. I probably even overcomplicated that, but yeah, my variable is 2. So the probability of selecting a green M&M would be 2 out of 7. Yeah, I'm thinking I overcomplicated that. Oh well. That's the front page. Back page. The Weather Channel predicts a 45% chance of a snowstorm on Saturday. Find the probability that we will not have a snowstorm. This one, I don't know why my voice is cracking. This one I would take 100%. That's all of the things that could happen. Essentially, it's going to snow or it's not. 100% minus 45% is going to give me my percentage that it's not going to snow. So it would be 65%. Nope, 55%. So 55% would be the answer. Determine if the events are mutually exclusive or not mutually exclusive. Mutually exclusive cannot happen together. not mutually exclusive, can happen together. So, for a deck of cards, which if there's any card questions on the quiz tomorrow, I'll have the deck of cards on the screen. A card pulled from a standard deck is a jack or a queen. A jack cannot be a queen, so this would be mutually exclusive. Okay. On a spinner numbered 1 to 5, it lands on a composite number or an even number. An even number, so if we have, let me just list this real quick to the side. If we have 1, 2, 3, 4, and 5, a composite number is not a prime number. So that would be, actually, let me highlight that. Composite number is not prime. 1 is neither composite or prime. 2 is prime, 3 is prime, 4 would be a composite number. Okay? And then the even numbers, with our numbers available here, are just 2 and 4. And since 4 has both of those colors, meaning it is composite and even, this would be not, not mutually exclusive. Okay, because they can happen at the same time. Number 9, numbers 1 through 20 are written on slips of paper. Find the probability of selecting a multiple of 2 or a multiple of 4. So again, I'm going to write this out. It might take a second though. 3. Okay, so there's 1 through 20. For my multiples of 2, that's going to be all of the even numbers. For my multiples of 7, that's just going to be 7 and 14. The next multiple of 7 would be 13. Or, sorry, 21. Okay, so you see we have 14 is doubled. So let me come back to that actually. I'm going to make this red so we identify what that means. If we're finding the probability here, right? So we want to find the probability of a multiple of 2. Whatever. You can ask me questions tomorrow. Probability of a multiple of 2, add that to the probability of a multiple of 7. And then what we're going to do is subtract, if we need to, the multiple of both. All right? So you'll notice my both and that 14 circled are in red. The probability of a multiple of 2 would be 2, 4, 6, 8, 10 out of 20. And then the multiple of 7 would be 2 out of 20. And we need to subtract the 1 out of 20 for that 14. So 10 out of 20 plus, well, 2 minus 1 is just 1, so plus 1 out of 20. I got 11 out of 20. Oops. Which is 0.55. So that would be my final probability for that one. Okay? Number 10, you are packing for a trip. You only want to pack 3 shirts, 2 pants, and 2 pairs of shoes. So this is a tree diagram. So we want shirts, pants, and shoes. Three shirts I'll call 1, 2, and 3. 2 pants I'll call A and B. And then 2 pairs of shoes, since I used letters and numbers already, let me just go with shoe 1, shoe 2. Shoes 1, shoes 2. I don't really have a better way to do that. That's okay. So we've got 3 shirts. The shirts that you choose and the pants that you choose and the shoes, like none of them, they don't really affect another, at least in terms of this math problem, right? So if you choose shirt 1, you can still have pants A or pants B. If you choose pants A, you can still have shoes 1 or shoes 2. Right? If you have pants B, you can still have shoes 1 or shoes 2. It's not going to affect that. Right? And if you have, going back to the shirts 2 is going to have all of these same combinations. This is going to get messy. Okay. Shirt 3 is going to have all of these combinations here. Right? Let me clean this up a little bit. I hate tree diagrams. All right. So that's kind of what we've got, right? And then in terms of the total combinations, you got 1, 2, 3. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 total combinations for this. All right. And then we have to list the sample space. So it would be like 1A shoes 1. Whatever, we can just list 1B, or sorry, 1A shoes 2. 1B shoes 1. 1B shoes 2. Okay, and all of these combinations are kind of going to repeat for shirt 2 and shirt 3. So those are all of your sample spaces. If you count those, they're all 12 there. You can use the counting principle though to determine the total possible number of combinations. It's super easy. You're just going to take your shirts, your pants, and your shoes, the total number for each, and multiply them like this. There are 3 shirts. There are 2 pants. There are 2 shoes. So 3 times 2 is 6, times 2 is 12. So you have 12 outcomes. or 12 combinations. That's it. If you guys have any questions, be sure to bring them to class tomorrow, but we are going to take our quiz and see how it goes.